Hello everyone, so today we're going to be doing Leetcode's number 3, longest substring without repeating characters. The problem says given a string as find the length of the longest substring without repeating characters. In example 1, we have s equals abc, abc, bb, and the output is 3 because there's two scenarios where the highest length is 3. So abc and abc. In example 2, all of them are the same character, so of course it will evaluate to 1. And example 3, there's two scenarios where it is a length of 3, which is WKE and KEW. And PW is also unique, but it's 2 less than 3. Yeah, so it's not, we want to get the highest length. So to solve this problem, we want to figure out how can we detect a duplicate. And to detect a duplicate is we can use a set. So what I mean by saying we can use a set is, let's use a scenario ABCA. Let's say we have 2 pointers and we're at this position, left and right. And we see that in this, we throw in the set based on if it's already added or not. So we see that A is currently in the set, right? We can just remove A. So it'll just be BCA. BC. And then we can add the other A and it'll be BCA. And basically we're using a set and taking advantage of its characteristics to detect duplicates. And to show you how it works in iterations. Also, I said we're using sliding window. We're gonna be using a sliding window. That's how we're gonna keep track of the length. To calculate the length, it's gonna be right minus left. So the right index minus the left index. Or it'll be right minus left plus 1. Just depends on how you implement it. So these are two ways to calculate the length. So this is the length right here. So highest length. And yeah, so that's how we're going to do it. But using the sliding window, it uses pointers. So we only increment or decrement the pointer based on the conditions. So we give it specific conditions on when to increment the left pointer or the right pointer. So let's say for the left pointer, we only increment it when we see a duplicate. And for the right pointer, we keep incrementing it and adding these things to that set. So in the first scenario, we're going to check, is A currently in the set? No, it's not. So we add it to the set. We're using right to add, the right pointer to add. So once we do that, we increment the right pointer. And the right pointer will be right that. In iteration 2, is B currently in the set? So the right pointer is checking, is B currently in the set? It's not. So we add B to the set as well. So the set currently holds AB. And we have A, B, C, A. Left pointer hasn't been incremented yet. This was a mistake right here. This should be the left pointer. And the right pointer will now increment to C. Now, is C currently in the set? C isn't currently in the set, so we add it and we increment the right pointer again. So it'll be A, B, C, A, left and right. Now, here's a scenario where you see a duplicate. So we're currently right here. Sorry, let me fix this mistake right here. Right, it actually should be right here. So A, B, C, A, and we have the right pointer right here. So is A currently in the set? Yes, it is. So what we want to do is remove the first occurrence of A. So remove this A and also increment the left pointer. If we don't increment the left pointer or remove the A, we're going to have an infinite loop. We're going to find a case where we have an infinite loop. And the loop we have running is while, let's do it in a different color, while the right pointer is less than the length of the current string we're using, which is ABCA. And the current string we're using is 4. And currently the index we're at is 3. So it's 0, 1. The right pointer is currently at 3. So now, is A currently in the set? Yes, it is. So we want to remove the first occurrence. So it's going to be BC and ABCA. We don't increment the right pointer. We actually increment the left pointer. In the fifth iteration, is A currently in the set? No, it's not. So now we can add A, BCA. So we have BCA in the set. We increment the right pointer again because we pre-increment it. So right pointer is actually going to be out here and the left pointer is right here. And the reason why this still works even though the while statement's right is less than length of S, it's going to pre-increment. So right will still be at index 4. So this would be 0, 1, 2, 3, 4. And now the program exits. So now the program exits because it exits the while statement. And we just return the highest length we get. Highest length. In this scenario, let's calculate the highest length. Well, we can do it in, I guess, blue. So the length currently. So the length in this scenario is currently 0 because we're taking the max of 0 and 0 minus 0. That equals 0. So the length in the first one is 0. And the length of the second iteration is going to be the max. The max of 0. By the way, this variable right here is going to be the highest length variable. So 0 and 1 minus 0. And the highest between these two is going to be 1. So highest length evaluates to 1. This in iteration 2. In iteration 3, we have the max. Highest length currently holds 1. And then it will be 2 minus 0. So by the way, the math is index 2 minus the index 0. So right minus left. And this evaluates to 2. Because between 1 and 2 is the highest length, and that's 2. So length is 2. I'll do one more because it's taking a bit of time. But currently, we're at this scenario where the max is 1. So let's say we're at this scenario. The max will be between 2 and 3 minus 0. Actually, that's a terrible scenario. Let's do a even better scenario. Yeah, in this scenario, it'll be max of 2 and 3 minus 0, which evaluates to 3. So that scenario is the length of 3. And when it's 2, it's actually going to be, yeah, this is good right here. So yeah, that's basically what we're going to be doing to calculate the length. We're just going to be taking we're going to have a variable called highest length. Just take the max of the highest length. And right minus left. This is how I'm going to be implementing my sliding window. So it takes the variable highest length, and let's say the highest length is currently 1 and right minus left is 2. Between those two, the max function would just pick 2. So highest length will be 2. Equals 2. Now we can implement this into code. Like I said, we're going to start with the set. So let's call our set hash set. And we're going to have 2 pointers, left equals 0 and right equals 0. And we also said we're going to keep the highest length, which initially is 0. And we're going to have a while loop to keep this running. So while right is less than the length of S, we're going to first check if S of left if s of right is in the hash set. So if s of right is in the hash set like this scenario, we want to remove this scenario. We want to remove the first occurrence of the set of the character. So we can do hash set dot remove s of left, and we increment the left pointer. And let's say if s of right is not in the hash set, right? We're gonna do hash set dot add and increment the right pointer. These are the scenarios where we were adding the characters and incrementing the right pointer. Adding the character, incrementing the right pointer. And now you want to calculate the highest length. And like I said, in this code, it just depends on how you implement the sliding window. So the way I'm implementing the sliding window, I'm gonna just do right minus left, so it'll be highest length and right minus left. And you can just return the highest length. Let's run it and see if it works. And yes, it passes all test cases. And yeah, it works. So the time complexity of this is going to be O of n. O of n. And that's because we're only iterating through the string once. But the memory complexity be the minimum of m and n. And m is the set of characters. N is the length of strings of the string. And basically what I mean is let's show an example where the memory complexity is at its best time complexity, where it's O of 1. Let's say we just have a string of A, and you only have one occurrence where there's unique characters, which is just the first scenario. And right pointer will just keep going over here, and the left pointer is right here. The left pointer never moves. The minimum between this is 1 and 1, 2, 3, 4, 5, 6, 7. It takes the minimum, so the time complexity is going to be O of 1. That's the best time complexity. So say we have like A, B, C, all the way up to Z. The alphabet holds 26 characters. So we can have left, right. All these characters are unique, so the worst time complexity is where it can be minimum of 26 and 26. And the time complexity right here, obviously you can see the worst time complexity is when the whole string is unique. But yeah, hope you guys enjoyed the video. Subscribe for more videos like this. Thank you so much.